Okay, hello and welcome to SunoikisisDC Digital Classics Summer Semester 2018. Today is our 7th session and the topic of today is Programming through Latin. We have two guests from the University of Florida, Eleni Bozia and Angelos Barmpoutis, and both have been contributing a lot to our work in Leipzig and also to SunoikisisDC Digital Classics. Probably for Angelos, this is the first time in Sunoukisis, but Eleni joined us many times for common sessions online. So welcome back and thank you for this contribution. And as usual, you have the class outline on a GitHub in our repository, and you have the description, you have seminar readings, the essay title. And the goal today is to present a novel method for integrating coding within existing liberal arts curricula and more specifically within classes. So this is going to be a very interesting session. So Angelos and Eleni, thank you very much and welcome back to Sunoikisis.
Hello, thank you, Monica. Thank you for having us.
Thank you for the introductions.
And do you want to start?
We can start sharing the slides. The PowerPoint should be somewhere. Yes.
Okay, I can see your screen. Okay.
Okay. Can you show the slides now?
And are they changing?
Yes, okay. It works. Perfect.
So thank you for having us. This is a very new initiative, and Angelos actually started that, and I thought that it would benefit a lot digital humanities and particularly also classics students. So this is why I wanted to get involved, and we applied it on Latin and Ancient Greek. So today we are going to show the entire concept, but we are also going to talk about challenges and advantages and perhaps disadvantages. I'm sure we will find both when we try to apply this coding programming using Greek, Ancient Greek and Latin and vice versa. So the whole idea is how we can teach programming easily to digital humanities students, classic students, students of liberal arts programs. Why would we want to do that, and how did we come up with this idea? I thought, and Angelos thought, that natural languages can find some correspondence with computer programming. We do realize, obviously, that natural languages are very rich compared to computer programming. However, there are the similarities, the bridge between the two, I feel that can be found in syntax and grammar. So syntax and grammar are very procedural, and this is the connecting point I felt that we can find between programming, coding, and teaching natural languages. Why would we want to do that? How can we integrate computer literacy into liberal arts curricula? Why and how can we motivate students and scholars, students both undergraduate and graduate, to acquire coding skills, and how we can do that? These are some of the questions, and the answer, one of the answers came to us when we were exploring NEH's, the funded digital humanities projects. Starting in 2011, the NEH, the Office of Digital Humanities, they started requiring a data management plan. So if you make, if you perform a search on the funded projects, 70 out of 108 funded projects involve the creation of open source programming, which means that, first of all, it needs to be produced. We need to create something, whether it is a database, whether we are working on a stylometric analysis, whether we are working on analyzing language on different levels, GIS, etc. We do need to develop computer code. And on several occasions, we need to rely on computer programmers, which presents other difficulties on its own accord. You need to find someone who is interested in working with you. You need to find someone who can understand what the needs are, what the problems are, what the research questions are for a humanist. But then, even if you are able to work with someone, to find someone, a computer programmer to do that, then you do have a complete program. You have a complete program, you have a complete tool, but that needs to be maintained. Which means that you either need to find someone to permanently basically fund someone, a computer programmer, to do that, or you need to have computer literate digital humanists and humanists in general to be able to maintain it, to be able to sustain it, to be able to add new options to it. This problem, this issue, this challenge does not only apply to humanists who want to develop their own program, but humanists who want to work on other open source tools, on other open source programs, usually when something is federally funded, or when you want it to be generally accessible, you make it open access, but also open source, which means that we have now multiple sources, multiple tools that we can use, but how many of us are actually able to use them efficiently, effectively, beyond what we can actually see, beyond the basic options that they offer us? And even when all these programs, when they are entirely open source, how many of us can actually contribute to them? How many of us can actually enhance them? So are they really accessible to humanities scholars? So this began basically from personal quests, from what I myself have been trying to do, what other colleagues have been trying to do, and also it came through my digital humanities course. The course itself consists of students from a variety of backgrounds. I have students from the Department of Classics, English, Anthropology, Linguistics, but I also have from the Computer Science department, and I will get back to them in a second. Or students who simply want to explore the potential of digital humanities. They all want to have some experience in programming, but it is usually very, very hard, not in reality very hard that they cannot come to terms with programming, but it's mostly freeze. You see a language that it's not something that you are used to. It's different from the language that you have been accustomed to learning, like Latin and Greek and English, Spanish, etc. So automatically you develop some apprehension. So how do you break this? Vicious cycle? How can you get people to understand that it's another type of language, but you can learn how to learn a language, and as long as you know how to learn the foundations of a language, you can basically learn anything. But there is another aspect, and now I'll go back to the computer programming students. Here in the US particularly, we have had an increase in the so-called STEM students, science, technology, engineering, and math. The underlying principle is that you have to choose between the two, that if you are good in programming or in STEM education, then you are not good in the humanities, and vice versa. After the financial crisis of 2008, everybody has drastically turned back to STEM education, which means that we have significantly less students in the humanities. So I wanted to find a way to explore different ways, not a way, but to explore different ways as to how we can bridge this gap. Now from the other side, not how you can break the freeze of humanities students learning programming, but how you can also explain to STEM students that as long as they can learn a programming language, it's procedural enough so that they can make their way back to the humanities and learn syntax and grammar for a natural language, any natural language. So the motivation for me came basically from two different aspects, from two different sides. Now all these questions, they are not new. They started basically back in the 1960s, and I have a couple of names, references for anyone who wants to explore the bibliography on that issue. But Alan Perlis argued that computer science should be part of liberal education, and that was in the early 1960s. And he also argued that all students should learn to program. Now, this may sound very fundamental, I don't know, not cutting edge, but it may sound like a sweeping declaration. But like I said, all students can learn how to program, and I believe that all students can also learn a new language. These are some other references to discussions, and as you can see, they all started back 1961, 62, 63, 65, and they all started exploring how we can integrate computer programming into liberal arts in general. There have been several attempts to do that, but and there are several, and Angelos will elaborate on that. There has been block programming and other attempts to teach the fundamental concepts of programming, but they have all been focusing mainly on K through 12 curricula, so they don't come close to the age group that we are working on. Basically, undergraduate students, graduate students, and then, like I said, scholars from any background. Discussions have continued exploring this topic. So how computer literacy can enhance the humanities, how computer literacy can be embedded into liberal arts curricula, etc. And if you just do a simple search in on the discussions on the humanists, you can find the train of thought of people, and that all these questions have kept coming up. Angelos, do you want to?
Now, in practice, what are the tools that have been made so that we can actually use them in classroom and motivate students of humanities, liberal arts curricula in general to get some basic knowledge of coding? There are several attempts. There are several nice examples that we can use here. We have in our slides just three. I think these are the most popular or uniquely different from each other. And Inform is one of them, which is a programming language. It's mostly a system that you drag and drop elements and connect lines. So it's a visual programming language, if you will, to design interactive fiction based on natural language. So we see this kind of connection between programming languages, natural languages, and the motivation that is given here to the students is that the actual tangible result that this program creates is an interactive text-based fiction. So you can write some smaller narrative, give some options to the users, and click and proceed to this interactive narrative as you go. And it is a nice example because it provides to the students again the key principles of problem solving and procedural languages, but it keeps the actual application to a very constrained topic of fiction. Write fiction in this using this tool. Another example is as they call it, Shakespearean programming language, or SPL, which is this esoteric programming language. It's not just a generic programming language. You cannot use it for a general purpose or create another tool using that. It's just for what it is, which is basically to make programs appear to be similar like Shakespearean plays. And there is a particular set of limited set of instructions, if you will, in this language, and the output, as I said, looks like a structured procedural playwright, very similar to Shakespearean plays. And again, the goal behind this project was exactly the same: to introduce students to these concepts, fundamental concepts of procedural languages, but of course keep the actual outcome of the project very constrained, very focused to the topic of, again, creative and narrative, or creative something that has to do with natural languages. Another example, which is somehow the opposite from the previous two cases, it's the project Metaphor, which visualizes stories as code. So in other words, we don't start from code, in this case, to produce a text, but we start from a text. The input is basically a paragraph, and it creates this, it analyzes this based on the grammar and syntax of the underlying input text that you provided, and converts that into some sort of structural computer-like syntax as code that separates again words and structure them according to the sentence or the period, the phrase that they belong. So you can author a paragraph in a natural language, and by observing, by studying the output, you can again establish some familiarity between the syntax of a real programming language by observing again what are the particular words that were translated into this type of code, and by this process you establish this type of familiarity. Of course, there are many others. We don't have the time to cover this, but there are several questions now to answer after this small survey, and maybe Eleni can continue from here.
So the question was initially, before we started considering developing our own tool, and before I guess reinventing the wheel, can these tools motivate students and scholars in the humanities to study programming? And can students and scholars learn how to code in a real programming language through those? So these were the questions slash motivation. So what should we do in order to make it easy for anyone to learn the process of learning? I usually tell my Greek and Latin students that if you learn how to learn one language, so if you learn the concept of learning, the fundamentals of a language, you can learn anything. So the idea behind this project is not only to teach programming and how students can learn how to code, but also how to understand the fundamental principles of coding. Based on that, they can then proceed to learn any programming language, the same way that if someone learns how to learn Latin, then he or she can proceed with ancient Greek and with other natural languages. So we started from these principles. And we covered that part. It has been studied, several different approaches. This is basically the summary of the presentation so far.
And going back to the actual tools for, again, successful approaches for coding that outside of the humanities, we will see that there are several approaches, and the main focus is on K-12 education. And we will show you three more tools, again, outside of the humanities for general purpose coding, how to introduce coding to beginners. And in K-12 education, we're talking about younger ages. The tools are categorized in three areas, those that address problem-solving skills on younger ages, and these are tangible interfaces with blocks and actual pieces that you can touch. So this is completely tangible user interfaces to introduce beginners, again, usually in younger ages, to coding. And then as you mature and you want to proceed to more complex programming structures, we have visual coding or graphical user interfaces that offer block-based coding interfaces where you can drag and drop different elements that relate to computer programming. But of course, the scope of these, again, is limited. It targets specific ages, and of course, these are not generic purpose languages that could be used for advancing a particular topic like the humanities. And of course, at the end of this pipeline of knowledge, if you want. We have the more mature tools, again, for introducing beginners to coding, that look very much like professional text editing tools, where we have text editing interface now. There's no visual or toy-like interfaces. You have to author code by obeying specific syntactic rules in a programming language, and the focus could be on to attract and motivate the users here. The focus could be on graphical design, create something visual, compose a shape out of primitive shapes, or it could be sound remixing, like EarSketch, that is the screenshot here on the right-hand side, where again, using specific simplistic programming languages in a text-based interface, you can produce a meaningful output, a tangible output, either, as I said, in the visual in a visual way, visual output, or auditory output as a sound remixing. So these three areas, and text editing interfaces, that is the last area of learning tools, are the most popular that are used in general, again, K through 12 education, and the last, of course, is used also in higher levels, in college levels as well. So, of course, we go back to the same questions. So, how can we integrate computer literacy into liberal arts curricula, and how can we, as Eleni said, reinvent the wheel in such a way that we motivate humanities students and scholars acquire the same coding skills? And this is basically the largest motivation behind this project. Now, a little bit of background regarding this particular methodology. It's a text replacement methodology that was introduced last year, very recently. And the idea is to replace every single token in a programming language, every symbol in this script, in a programming script, with a visual or textual explanation, with something that is an explanatory statement. And the advantages, of course, is that it hides all this jargon from the beginners, all these symbols that are hard to understand, especially, again, if you are in the early stages of learning. And, of course, by replacing them with something much more explanatory, students can read the logic of the program. So we don't need to worry about how it was written, what is the underlying syntax. We can just focus directly on what it does, on the logic. So it reveals instantly the logic of the program. And this text replacement is interactive. Basically, as you type a particular token, the moment that you finish typing this, it is being replaced by this explanatory statement. Therefore, it is a try and error environment. If you type something, or if you mistype something, then the explanatory statement will be different, explaining what you really typed, and if the intention was to type something else, the logic that you read will reveal that. Therefore, you can go back and erase it and retype it. So it offers a learning environment for beginners to type and understand what they typed, basically, in a natural language. And as I said, we can use real programming languages and replace the tokens of the real programming languages. And I believe that the most popular, at least among the humanities students and scholars, are like Python, R, possibly others like JavaScript, Java. So we can dress these languages with this explanatory statement and make it possible that you open someone else's script, an existing script in Python or R, that does something useful for your discipline, and read the logic of the code and possibly start editing and learning from that using this text replacement method.
So this idea, I felt that it would apply on classics, for example, students. It felt somehow as the prose composition that we do when they give us a text in English and we need to translate it in Greek or Latin. You have an input in another language, and then you need to find the correct process to turn it into Greek and or Latin and find the syntactical and grammatical errors. So this is one of the aspects that I found very interesting in this particular methodology.
Now we have a question for you, and maybe you can post your answer or later in YouTube. But we have this question. We posed this question in the conferences where this was originally presented. So I asked the audience if they know coding, whatever is their level, doesn't matter, maybe a little bit of web coding for creating a website or in some other language. And I'm asking that because I follow with another question. So for those, or for anyone, can you understand a statement like this one? So we have some symbols. We have some words over here. The audience spends usually a few seconds thinking about that, and after that, I follow up with another question. So, what about this statement? Now, this is a combination of some visual characters like smiley faces and some English that resembles what we see recently in social media or text messages. And this could make much more sense compared to the previous equivalent expression. So this example shows us that basically in computer typing, the symmetry between what we type and what we actually read or what we intend to read is breaks. It's not symmetric. What we type could be slightly different from what we intend the reader to see. And the reason for that is because using a shortcut for creating one of these visual replacements, a smiley face, what we do, we memorize basically a combination of characters like the semicolon or the colon and the closing parentheses, and we, as often we do this type of shortcut typing of emoticons, we memorize this convention. So the typing is the action. Basically, what we see is the cognition. So this alteration of typing, action, and cognition basically creates the knowledge in our brain, and we register this information so that we can easily do it. And of course, this is done not only in typing, but in many other forms of using shortcuts or typing shortcuts in computers. For instance, how we type Chinese logograms, or how we do Control-Alt-Delete in. Have we stopped the presentation? I think. Or can you still see the presentation?
No, now I
think we stopped.
I see no screen, but I see many windows. Maybe we can try.
Sorry about that.
Maybe stop share.
I think this is the main window. So.
Okay, now is fine. It works.
Yes. So as I said, we have this type of operating the computer through commands and registering these with the action that they reveal. Now, in practice, in programming, uses symbols like characters, combination of characters to express with that particular instruction, so that the computer can perform a sequence of commands and create a useful output. It is interesting that students, I asked in my class this very simple question: how to type a smiley face? What are the two characters to type a smiley face? And 98%, so almost everybody, correctly identified the colon and the closing parentheses as the two symbols for that. However, after 15 weeks of introductory lessons in computer programming, and after having seen a particular combination of two characters for typing a comment in a programming language, and this corresponds to 2 slash lines. So after having seen this combination of 2 characters for more than 200 times in this 15-week period of lessons, only 75% were able to identify what is, again, the same complexity, 2-character symbol in computer programming that does create a comment in your, introduce a comment in your programs. And only 3 out of 4 knew how to correctly identify these 2 characters. So we have a similar question. The complexity of the question was very similar. 2 characters. You had to identify 2 characters in both of these. But of course, one was much more familiar. That's why everybody identified that, or almost everybody identified that properly. However, a similar complexity, again, question could not be successfully identified by all the students that relates to the programming. So can we then dress similarly to what we do with emoticoding, every combination of characters or tokens in a programming language with something much more explanatory? And this could be a natural language. For instance, here I have a script in a programming language on the left-hand side, and an equivalent script with some sort of text replacement, where we have overlaid, if you will, every single token of the script on the left-hand side with a word or a phrase in English, in this particular case, on the script that is shown on the right-hand side. This is this type of coding, because of the resemblance of this use of shortcuts for emoticon typing. We call it emoticon-like scripting or emoticoding here, because the moment that we complete each of these tokens, the corresponding phrase or word appears. And of course, it doesn't have to be fully in text. It could be more colorful, depending on what is the audience that we want to attract here. If it is younger ages, maybe it could be more visual, more decorated. If it is more mature ages, it could be more simpler, like the text on the top. And of course, if we focus the outcome to particular topics, we can create certain instructions, commands that have very particular focus, for instance, geometry, and I'm going back again to younger ages. So the corresponding commands could be replaced with something much more visual, maybe puzzle pieces here, maybe with something that relates to geometry, if this is what these commands do here. And we will see how, again, each of these tokens could be visually replaced with this particular set of visual and textual replacement. Or music, again, for younger children, how can someone learn both the music notation, and we can see on the right-hand side the equivalent visual replacements of the code on the left-hand side, where we have music notation. So someone who learns both, they can combine these in this kind of interactive text replacement or visual replacement mode. So that's the general idea, and of course this could be applied to virtually any topic. The only challenge is to identify what are the particular replacements of the tokens that you want to create, so that it motivates a particular type of students, particular age of students, maybe particular area of study for the students. And after testing some of these versions of the interface in college-level students and contradicting that, comparing that with traditional, conventional coding in a regular text editing with editor without any text replacement, just you see what you type, we will see significant advantage in terms of syntax recall. The students were able to recall the underlying syntax of the real programming language much easier after using these text replacements. And the syntax discovery, understanding new syntactical features from the underlying programming language, syntax error reduction, runtime error reduction. We have seen significant improvement in all these using this methodology. And if you ask those students at the end of this experimentation, if you will, with this new tool, a significant percentage of them said that it's easier to understand the logic using that. It challenges me more to learn the syntax, improves the learning performance. It's useful overall, easy overall, and makes me skillful in programming and flexible to interact. So starting with this basis, and having this early proof that this could work and could be done in a certain way to motivate particular students, the questions going back to the humanities is, how can we apply that again to the humanities? Can we apply this to do similar experimentation and motivate the students in liberal arts, and how this is possible?
And initially we started, like I said, from personal interest, we started with classics, but then we had to refer to, and we wanted to refer to the humanities. But when you are talking about the humanities, I like to believe that each one of the humanities fields is independent, but we also work under the big umbrella of the humanities, and we are all connected. And each one of the humanities fields, or of several humanities fields, has to do somehow with some sort of natural language. And we distinguished humanities fields into three distinct, I hope at least distinct categories. Disciplines that study languages, and my primary example is going to be classics. Again, we learn primarily ancient Greek and Latin. And then there are other disciplines that use languages as tool. And again, my mind went to history. They do not necessarily need to learn a language, but if they want to study the sources in their original language, they are going to use language, but mostly as a tool, not in the way that a classic student is going to learn a language. And then other disciplines that use language for creative writing and critical thinking. And of course, we have primarily English department, but that can also apply in anthropology, archaeology. Archaeology can also fall into the previous category, languages that, disciplines that use language as a tool. So like I said, we have humanities disciplines functioning independently as separate fields, but they also work, all of them, under the umbrella of the humanities, and they relate in different ways with language. But again, natural language is the common element for each one of those disciplines and others that I haven't mentioned. So here is a screenshot of those text replacements in English, what you can see on top, but also on your left-hand side on the bottom in Latin, translated into Latin, and the other one translated into Greek. For the Latin translation, we use some of my graduate students in classics, graduate students in classics, and the ancient Greek I translated myself, but when this is available, Angelos is going to show you the link online, and we invite comments, suggestions, corrections. This is only the first attempt, and we are going to talk in a little bit about the challenges. Because, as I said at the beginning, yes, I do believe that there are connections, procedural connections between coding and learning syntax in natural languages. But you can, there are also issues of lack of richness when we are going back to the programming languages. So questions, challenges, problems that we faced at the beginning, and again, mind you, as Angelos said, we are still at the beginning. We just started doing that, and particularly the translation into ancient Greek and Latin. Is straight alignment possible? And we have examples that we'll show you later. When you want to do, for example, a genitive of possession, it works differently. Or when you want to denote possession, it works differently in Latin and Greek. It works differently in ancient Greek than in modern Greek. The word order changes. Also the case. You can have genitive, you can have dative of possession. So how can we do, if straight alignment is not possible between ancient Greek and Latin, and they are both, they are very closely connected, is straight alignment possible when we are working our way through and between natural language and programming language? And if it is not possible, is this going to be, is this going to obstruct humanities students from learning programming, or from computer science students from learning a natural language? Or can we find a way to bridge this gap, which is also going to be very productive and when I say productive, I mean in terms of exposing students to the difficulties, and thus exposing them and familiarizing them with the language, any language, depending on what they are working on. So this led us to several grammatical and syntactical issues that we had to face in the translation. Declension, like I said before, the different cases, the word order. And also that went to what natural languages can be used. We realized that on occasion, modern language, and that will make sense, but and it may seem very reasonable and very naive and simplistic, but we actually had to realize that while we were working towards translation, we realized that it's easier when we are working with modern languages, and it does make sense. I realized that now that I came to that conclusion, since programming languages came out of English and in modern times. So it was a lot harder when we try to work our way backwards and do that in ancient Greek and Latin. And this issue appears again on from the other perspective, the opposite perspective, what programming languages can be used. So not everything can be, I'm going to use the word translate loosely. So not everything can be translated in and from any natural language and from and into any programming language.
And now we can go to the actual tool and experience some of these problems in practice and see the result that we have so far in practice. And of course, we have shared with you on the Sunoukisis website the actual link if you want to experience that yourself. Now, coding involves, as we said, text editing, and the input, if we want to learn or practice in a professional programming language, has to obey the syntax of the particular language. And here we provide, as an example, JavaScript, but this concept could obviously be applied to other languages, such as like Python, R, and others that we plan to utilize in the future. So now, for someone who is beginner in programming language, in JavaScript, for instance, we have this notion of variables, and which is a data, a small data piece in your program, and to declare that, you have to type expression that has several symbols and keywords, similar. Like that, for instance. So it is basically a command that is that consists of several tokens. Here, the first one is a keyword. Then you have the freedom to define anything you want. For instance, if this is like score, I can say that the score is 0. If it is number of sentences, if it is the age, if it is a date or something. So the user has the flexibility to define that. But this expression is followed by another symbol here, a value, and basically defines, instructs the computer that there is a quantity that I want you to know about. It is number, and the value is 0 in this particular case. And of course, there are symbols that alter this number. For instance, later we can say, okay, now we have the game has, let's say, progressed, and now the number has increased by 1. So there are symbols like this one for the beginner, of course, and I guess this is the case for several in our audience. It's hard to understand what this symbol means because, again, it involves it's a combination of characters and symbols here plus equals, and you have to learn that. And if you open a script that looks like that, and I will continue typing just a few more expressions to show you the complexity of a programming language. There are other symbols that use two times here the symbol of equality, and you can see that this is different from the first occasion here where I use the same symbol once. So there is a different meaning here, and of course there are other symbols like the 2 times the vertical line, or even the exclamation mark and equality, or something like that. And of course I can continue typing more code in here in this form. But now, if you know programming, go into try to get into the mindset of a beginner, and all these symbols and expressions is very hard and difficult to understand. So the logic is not obvious here to what this little script does, and this is the biggest challenge and leads to, as we call it, blank page trap. Now, utilizing this method of text replacements, I'm going to delete that, and I'm going to turn on, for the beginning, the English text replacements, and then we will show the equivalent in Latin. I will try to type something similar. You remember the first expression had the keyword var here. But the moment that I complete this, it is being replaced with something explanatory, and here it has been replaced with the phrase, or with the word let in English. And I will continue typing again the same JavaScript code. So what I type and what I learn and what I practice is the real programming language. I'm not inventing a new language. This is not a new language. This is the real professional languages. And as I said, this can be applied to other languages as well. But the moment that I continue typing, let's say the symbol equals, and it's being replaced with, again, an explanatory statement word. So now the first line, the first command, although it's exactly the same as I typed it before without text replacement using the conventional text editor, now for a beginner, it's very different because it makes sense. It is readable, first of all. It uses natural language. Words or phrases, as we will see shown in other text replacements, that have all been overlaid on top of these symbols, jargons. So if I continue typing the example that I had before, and I use this plus equals, which is, again, hard to understand if you are a beginner. But the moment that I finish typing this particular symbol and I continue, it is, again, being replaced by something that explains the logic behind this symbol. And now it reads number be increased by 1, and I will continue with a statement that I had before. I used 2 times the equal symbol before. And now, if I proceed, it tells me that basically it tests equality. So I have a statement that reads, if number is equal to 0, and in my previous example, I used 2 times this vertical line, and now if I proceed, it is being replaced to the word or, which basically explains what this symbol was. And I will continue with something like that, and of course I will continue writing more let's say, symbols. Let me type just one more, although this is not an actual meaningful program that does something. I tried to use here different expressions within the same script to show you a variety of text replacements. Now, what is the advantage of this text editor? Besides the fact that I can now read the logic of the program without worrying about the underlying jargon. So a student clearly can read these expressions. If number is equal to 0 or number is not equal to 1, then do the following, which is a number be increased by 1 and so on. So it's instructions, of course, it's a structure, it's a procedural language. Of course, that's the content of a program. But one of the key advantages is that I can go back and delete what I. So it's an editor. It's an interactive. I can go back here, and I just using my arrow keys as if this was a regular text editor, and press backspace to delete a token. And the underlying jargon is never lost here. So in this particular instance, I had exclamation mark equals, and that's still there. It is being replaced only when I'm not typing that particular area of the text. But if I wanted to correct it or delete it, update the code in that particular case, still I'm working on the real programming language, which is very intuitive for the beginners to go and self-correct themselves. For instance, this statement makes sense. If number is equal to 0, do something, and then maybe I will simplify it for you. But very often, beginners get confused about the single equal sign, which means clearly here, B, it's an instruction to instruct number to take a particular value, to become 0, compared to the other instance where we use 2 equal signs, which is something completely different. It is testing here if the number is equal to 0 without instructing anybody. So here, if I, by mistake, forget about this difference of these symbols and I use erroneously the single equal sign, the expression doesn't make much sense. In English, if number be 0, so I'm instructing the number here, but at the same time I'm asking also. So from our experience, it helps beginners to go back and self-correct and reflect on what they wrote. The code here reveals what exactly they wrote. This is exactly what they wrote. But by reading it and reflecting on what you typed, you realize that, well, this doesn't really make sense to me, and probably it's not what I intended to type. And this, of course, leads to learning and remembering easier the underlying syntax, self-correct yourself, and see this as a space of try and error. I will type, or I will copy an existing code that I found online, paste it in here, and read the code in English, and be able to manipulate existing code by, again, going symbol by symbol and see what these translations refer to. Now, this is the general concept, and of course, we have used this translation for many other symbols, and I will use a slightly different maybe script for my next example. But now imagine that in order to motivate, to introduce coding in a particular classroom, in Latin students, as Eleni said, we need to provide a reason why, and why in this particular classroom. And of course, although the reason is evident regarding all these nice tools that they could use to advance their own research in terms of text analysis, but of course, they lack these fundamental programming principles, and you have to pass through this learning phase. So this equivalent tool, but in Latin, and I will open now the Latin scheme, could be used to, again, to have fun and experiment through, again, coding by creating, again, a script that is going to be overlaid in Latin, a language that is much more familiar to that particular audience. If we want to introduce to classic students, again, students who learn and practice Latin, if we want to introduce to this particular student body programming. So, for instance, I can do exactly the same thing. But of course, the students have now the advantage to define their own variables here. Of course, they can read the statement in Latin, but they have the freedom to maybe define the variables in a in a way that fits the language itself. So it could be typed as a Latin word in the first place. And of course, I will continue practicing JavaScript here, typing plus equals, and if you remember what this means, for a student, again, in Latin, if we go into their mindset, now this looks like an unusual script in Latin, which again, it's as I said, it's unusual. It's an interesting experiment to see how this works in terms of motivational element for these students in action. But it again exposes them to a real programming languages. But at the end, it creates this experience where they reflect on the code using Latin. So they have to again to see what how this what the translation means here, and what is the corresponding symbols behind that. And I will write an expression, for instance. Let me delete this statement, and I will say while and this is just a small script that iterates for 10 times. Now, we have a statement that in English basically means while the number is smaller than 10, then start doing the following, increase the number by 1. So for 10 times, I will do that as long as the number remains smaller than 10 here. So there are several underlying programming principles that they learn just from this very simple example. And of course, if we provide an additional set of functions that produce something, because this is an executable code, you can click run, and if it produces something meaningful, for instance, prints out some text, prints out a few numbers, or something that could be within their interest, then that could be an additional advantage to this way of practicing. Now there are some practical issues. What is being translated are the actual symbols that are defined in the particular language here in JavaScript. But what the user defines, for instance, as I said, the user has the flexibility to define the names of the variables here. It is their freedom to define it as in any way they want, and we don't replace the user-defined elements in any instance of the program. So the user could simply could have chosen in the first case to use an English word here, which of course does not blend with the rest of the translation, but because it's a user-defined, we can let the user define the variables with again, meaningful word, either in English or in another Latin-based language, and here we will see a mix of English words, those that are not translated automatically by the program because these are user-defined, combined with again those that are automatically translated. Again, it's an interesting process to see what the users will define as their own names for variables, and how they will treat these as they are being blended with the rest of the code that is automatically translated in Latin. And of course, I will use other symbols as well. And let me create a new example, and let me delete some of these. Let's say sentence, and I will use a few other keywords that I haven't used so far. In programming, there is the so-called object-oriented programming, which is a very common type of organizing your code, modern code, let's say, and many of the APIs obey to this style of coding. And in this type of examples, you define objects. So, for instance, a sentence is a new object, and let's say, something like that. Now, the symbols, for instance, that I use the keyword new, and I'm going to switch back to the English translation for a minute here. It reads, let sentence be a new object of type, and here is the type, for instance, so that could be, let's say, corpus or some particular type. And then the sentence has properties. So, for instance, there is another syntactical feature in programming that you can access properties of the sentence. For instance, the words. Let's say the sentence has 5 words. So using again this object-oriented programming syntax, every symbol is translated. So I used here the symbol dot to refer to the words of the sentence, and I instruct that this sentence has 5 words or something like that here. But again, using this type of coding, it translates instantly what this means. Or I can have sentence dot I don't know, reverse or do something, analyze, and this is not a property, but it's an action that you can instruct to a sentence to do if this was part of this particular given API of the corpus. And of course, the symbol here, although it is exactly the same as above, I basically replaced the symbol dot. Based on the context here, because I used parentheses and a few other symbols here, the editor itself, from the contents, understands that this is not a property anymore of the sentence, like the words in here, but it's an action that the sentence can perform for you. Therefore, the proper translation for that is sentence, do analyze, or do perform something here. So this is typically a verb. Now, if I go back to the Latin translation, we have some interesting problems. And one of them is, how do we translate this first dot that basically is the genitive of possession? So words is a property of the sentence. In English, we had a couple of ways. For instance, we said words of sentence, but that would reverse the alignment between the natural language and the programming language. In the syntax in the programming language, the order is first you have basically the owner of the property, then you have a symbol to define this ownership, and then you have the property that is being owned. So in English, we have the expression apostrophe S. So we can say sentences words be 5. Now in Latin, we have a certain problems, and maybe Eleni wants to just briefly mention what we see here.
So the way that we try to work way around that is by adding the ending, the default, let's say, genitive ending in Latin with -I to indicate that this is going to be this is meant to be a genitive of possession. While in the second case, where we want to instruct the sentence to do something, in Latin that would be with the imperative. But we also dealt with that. If you want to show the example in ancient Greek, we also had to deal with that in ancient Greek. So we had the same problem here. In this case, and again experimentally, instead of having a genitive, we decided to do the article. So we have the genitive to as basically kind of a default genitive pointing back to sentence. So in this case, this is a very good example of the challenges that we have. Yes, there is obviously possession. Yes, it can be translated, but if we didn't want to break the word order, in that case, the word order of the programming language, we had in a way to try to accommodate the natural language to the to coding, but without making and without making a mistake, and basically without infiltrating into the grammatical propriety, but in a way we had to flex the syntactical propriety. But still, it is. I think that it is clear that the first one denotes possession. The second one prompts you to execute a particular function. And as you can see, even between ancient Greek and Latin, we might have had an issue in Latin, which we didn't face in ancient Greek, or vice versa.
And of course, now the question is how again this particular interface can accommodate different audiences. And of course, in addition to the particular focus that we described of students of classics to basically use an existing API here and be able to read it and analyze it and edit it using a familiar language or a language that within their area of research, like Latin or ancient Greek. That could be also done for a natural language, native natural language of students from non-English backgrounds. And it is true that the raw English, and if I go back to the regular code that corresponds to the same script, uses keywords, and here we have just few var for variable, new, but there are other keywords like if, else, while, that are borrowed from English language. Now, for students who are not native speakers of English language, obviously this adds an additional layer of complexity in learning coding, because you have to learn a few English, if you will. So following the same example, this type of coding could be done in modern languages as well. And here, at least in the state of Florida, we have significant population that natively speak Spanish. And this could be a modality. And here I show, again, the same code as was typed in or overlaid in Spanish here. Could help them naturally again understand the logic in a language, in their own native language. And of course, the question is, can we do that with any natural languages? And what about like German or Arabic languages, Chinese languages? And we have started experimenting with this as well. But Eleni?
Yes, interestingly enough, even though I don't speak Spanish, but there is the same issue here with the genitive, the way that you need to do to denote and kind of reverse the word order.
Exactly. So in order to maintain like a straight alignment between the code and the translation, so that it registers on the user's brain the actual underlying syntax of the programming language that you learn here. We have to invent new ways like this arrow to define that words of the sentence. So the of basically refers to the sentence. Something that in other languages like Turkish, for instance, we have a similar expression like the English '*s, where we don't need to, again, invent additional elements like the arrow, and the students can immediately make sense of this statement. And we have a similar in Chinese as well, where there is a symbol there, here the logogram there for exactly the same thing. And again, it assists the students see the code in something that is much more familiar to them. Now, in and I know that our time is almost over, so let me go back maybe to English. In the Sunaikisis page, in addition to the readings, we have a few exercises for you. We provide a link that lists several expressions of standard programming expressions in a programming language. Let me actually click that, and I will zoom a little bit so that it is properly streamed online. This script does not make a particular, does not create something useful and useful output, but it lists all possible different expressions. So you will see several combination of symbols, plus, plus, minus, minus, and all that. Now, by switching to another language like English, you will see how this could be, all of these different types of symbols could be replaced in that particular language. So the exercise is basically, can you find alternative ways or better ways to improve these alignments, and not only the text alignment between the code and the particular language, but also within these phrases, if there is an alternative phrase that could be used in order to simplify the statement and make the logic simpler. Especially in a language of your interest. For instance, if we select again, going back to Latin here, we can see how we can create here a variable, define a variable that is true, that has a true value or false value, or we can see statements here, how to create like an inline object, even how to access arrays. For those who are more competent in programming, you will see several of these, how to manipulate the value, numerical value of the variable by increasing it or decreasing it by a certain interval, or multiply, dividing, or test the equalities and inequalities here in different ways. And of course, have different expressions like if, or otherwise, else, if, or of course, how to iterate in different ways, even how to try and catch errors. And as well as how to split into different ways using a switch statement here. But of course, it's interesting to do exactly the same exercise also in other languages within your, again, focus. And Ancient Greek is another example where we can see how you can read, again, the same sequence of commands, all possible expressions, or most popular expressions in programming languages, as it is being replaced here in expressions in Ancient Greek or other languages. But we invite you also, and I will go back to the Sunoikisis website, not only to study these replacements and identify the correspondences between the underlying programming tokens and the natural language phrases, but also, if you are proficient in natural language, and I know part of the audience is native speakers of German, that we do not provide currently a set of German text replacements. This is an interesting challenge to answer basically these questions. Can a similar set of text replacements be done in German? Can the word order be maintained using a straight or almost straight alignment, like the problematic areas that we discussed here, and how we can solve that in German? Or of course, if you are proficient in another language, Italian, possibly French, it would be interesting to do this exercise on, again, your language of interest. And we will be happy to review your answers, and of course include them, if you feel, with your permission, in the software, so we can make it accessible to more students from more disciplines, more countries, so that we can ease the integration of computer programming into various curricula, with focus, of course, to liberal arts curriculum. Do you want to switch to the PowerPoint? Do you want to add? Do you have anything to add on that?
That you shouldn't be, when you start, and if you decide to start working on that, talking from personal experience, it's going to be a cultural shock at first. Particularly if you try to work your way through Latin and Ancient Greek. It's the questions, trying to translate, for example, let a robot be, to translate it and use the word robot in an Ancient Greek or Latin sentence, was a revelation. But when you start working, when it's actually compiled, then it gives you a different insight, both into your original language, your natural language, Latin, Greek, etc. And obviously it gives you a better understanding, at least it gave to me and a few students that I have tried it on. It gives you a different understanding also into programming, a different insight.
And it is an experiment that we have started, and the next phase is where we plan to go from here with this tool. We want to experiment how this could be integrated into different types of disciplines. Let's say English curricula in history, maybe archaeology, so that we can introduce different, again, humanities students, into coding through a modality that is slightly more familiar to them, and maybe motivate them slightly more than the other existing tools. Of course, in combination with some useful API that will perform something tangible, possibly some text analysis for them using maybe a stylometric API that is available online, or other tools. But that is what we plan to do, to actually integrate it in classrooms. And if in your practice you use it, we will be happy to receive your feedback, and what are the best practices in integrating, again, coding into liberal arts curriculum.
Oh, thank you.
Thank you.
Let me stop sharing.
Thank you very much. It was great, really, a lot of fun, I have to say. And well, it's shocking for many people, in the sense for both humanists and computer scientists, for humanists to learn really Greek and Latin and how to express commands in Greek and Latin, and I'm sure, especially for traditional computer scientists, to use natural language. So really, it was great. And I also, given that, well, for the audience, Eleni and Angelos, they will come to Leipzig next week. They visit us many times per year, so, and they will be with us, and I hope you can meet my students and our students to see their reactions. Well, now I have a question in the chat, because we have Anise Ferreira from Brazil. She doesn't have a good connection, so she writes her comments in the chat. I hope you can, Angelos and Eleni, I hope you can see the chat in the Google Hangout. So she said, okay, this is amazing. I confess that I saw for the first the emoticons before trying to understand the program syntax and imagine how Oxygen would be like with emoticon interface.
So thank you for the positive feedback, Anis. And the question that you have here is, how long is the JavaScript vocabulary? Very good question. And how many are the statements in order to translate it to other natural languages? The example, the link that we provide as part of the questions for the audience lists those possible expressions. So the vocabulary is limited, and when I scrolled the script, it was no more than 80 lines to my memory, so it's not as big, obviously, as in a natural language, very limited. And if you want to go over that script and translate it in Portuguese, I guess, that could be done from my interaction with students who performed this, could be done within 2 hours. So just to try to come up with the proper word order and expressions in your own language, translating those 80 lines, yeah, the complexity is about 2 hours, and we will appreciate if you could provide those in Portuguese.
And actually, Anissa, it took us long for Latin and Ancient Greek. It's at the beginning it's harder because you need to get into the mindset, but once you get the hang of it, it's actually fun. You can get. I also try to get creative with Ancient Greek, but I had to limit, let's say, my creativity at the end. But it doesn't take longer. Whatever, no matter the difficulty, it doesn't take longer than 2 hours.
Well, I can imagine. Maybe for Latin, I know that, so now they are trying to not invent, but produce Latin words, or also for modern terms, but for ancient Greek, I don't think so. Anyway, this is a great, yeah, Eleni, please.
But that's the idea. I didn't want, at least for the, I don't know how the program is going to develop, but I didn't want us to come up with words for Greek and Latin. I wanted to be pure programming. That's why the issue with the genitive. And I wanted it also to be pure Greek and Latin. That way, we do not offend either language. We do not infiltrate any language, and we can find a way to actually make them coexist, but without having an incest between the languages. So that's why I wanted it to keep it a robot in English, even though blending it with ancient Greek, that was, and I was working my way through it with Angelos, and he kept asking me, so what's the most natural way that you can say this in ancient Greek? And I was telling him, you know, that this question doesn't make any sense whatsoever.
Well, I can imagine. Well, this is great because, yes, poor classical Greek for programming. And I think, no, this is very, very important, not only for our programs in at the university level in the United States, but also here in Europe. I'm working in Germany. We have a Bachelor of Science in Digital Humanities, where we have a mixed audience. We have humanists, they want to learn how to program. We have computer scientists who need to learn more about the humanities, but also the level of high school. I can mention that because originally I come from Italy, where we still have the so-called Liceo Classico, where students still learn Greek and Latin, but now we have a big debate. Do we still need Greek, or can students nowadays they can still learn Greek in the traditional way? No, they can't, because in this new world, the traditional way is not possible with, and so, but this is really a fantastic way to show how you can learn real Greek, as you said, pure Greek, not an invention, while programming. And you can learn how to program, and at the same time you can learn ancient languages. So, and as we can see, you at some point you really need to know the language, ancient languages, because it's difficult. And Eleni, you are a professor of classics, and as you said, it was difficult. Even if I know ancient languages very well, it's difficult, because sometimes there is this prejudice, okay, we use these tools, but it's not real Greek or Latin. No, it's real. It's a practical.
Exactly. Otherwise, you give them, more traditionalists in both areas. I'm not only talking about traditional humanists or traditional computer scientists, both. You're giving them an argument against actually moving forward and coming to terms with both. And what we've seen here in the States, it's really dramatic. People are literally dropping out of humanities. They come to us and they say, oh my God, I love it, but I have to choose. Maybe you don't need to choose in that sense.
Yeah, no, exactly. But also here in Europe, we have the same problem. So really, thank you very much. It was great. And going back to Brazil, well, I know that we have a strong community there, so maybe we will have people also producing something in Portuguese. This is for Anise, I know them because I was there. Well, now, unfortunately, our time is over. But really, thank you very much. And because, well, Eleni and Angelos, they have been working on many different projects. And this is the last gift, I can say, for our community, and this was perfect for Sunoi. And just as a parenthesis, Eleni and Angelos will be in Leipzig also because now they are part of the Digital Rosetta Stone project, and we will have our mission to London in 1 month to take pictures of the Rosetta Stone. So I'm sure that thanks to Angelos and Eleni, we will be able to produce new great things. Well, now, yes, I have to finish this session, unfortunately. So thank you again for your time, your work, and your contribution to Sunoikisis. And well, everything for the audience, everything is online. You have now the YouTube video, the class outline, and I know that you will also add the slides. Next week, we have another session on Latin and Sanskrit translation alignment with Neven Jovanovic from the University of Zagreb. So we have our friends from Croatia, and so we will have Neven and his students. So thank you again, and well, good night for those in my time zone, and for you, enjoy your lunch, and also Anita, and well, see you next week in Leipzig.
Thank you.
Thank you.
Thank you. Bye.
Bye. Ciao. Bye bye.